Welcome to Unit 3 of learning the course Design and Analysis of Algorithms. In our previous 2 units, we learned various concepts related to the course Design and Analysis of Algorithms. In the first unit, we learned the basic concepts related to the course Design and Analysis of Algorithms. Those basic concepts are nothing but algorithm, pseudocode, performance analysis, asymptotic notations, randomized algorithms, and various basic data structures such as sets, graphs, etc. In our second unit, we learned the 2 algorithm design techniques, greedy method and divide and conquer method. The 2 algorithm design techniques that we learned, we seen their general method and we solved various applications such as merge sort, quick sort, binary search and Strasson's matrix multiplication in case of divide and conquer, and knapsack problem, job sequencing with deadlines, minimum cost spanning trees, and tree vertex splitting problem, etc. in the greedy method. Now we are from this session we are going to explain about the third unit of this course, which explains the algorithm design technique, which is nothing but dynamic programming. Now here from this session onwards, we are going to know about the algorithm design technique, dynamic programming, and we are going to solve various applications by following that algorithm design technique, which is nothing but dynamic programming. The main objectives of this unit are learning the general method of dynamic programming, applying dynamic programming in developing algorithms to solve various applications, analyzing the algorithms for their time and space complexities. The outcomes of this session, this unit are the learning outcomes of this unit are understand dynamic programming algorithm design strategy, solve applications by developing algorithms in this strategy, and analyze the algorithms for their performance. Coming to the syllabus, this unit entirely divided into 7 sessions. In the first session, we are going to know about the general method of dynamic programming. From the second session to 7th session, we are going to solve various applications which can be solved by using our dynamic programming algorithm design strategy. Those applications are multi-stage graphs, optimal binary search trees, matrix chain multiplication, 0 by 1 knapsack problem, all pairs shortest path problem, and traveling salesperson problem. All these applications that we are going to solve. Welcome to session 1 of unit 3 in learning the course Design and Analysis of Algorithms. In this session, we are going to discuss about the general method of dynamic programming algorithm design strategy. The main objectives of this session are to learn the general method of dynamic programming. The learning outcomes of this session are, by listening this session, one can understand what is the general method of dynamic programming and able to follow dynamic programming strategy to develop algorithms for solving various applications. The topics that we are going to discuss in this session are the general method of dynamic programming, steps in dynamic programming, components of dynamic programming, and principle of optimality. Coming to the general method of dynamic programming. Now, where we are using dynamic programming? The dynamic programming can be used to solve optimization problems. What are the various types of problems that we have first? We have mainly 2 types of problems. One are decision problems and other are optimization problems. We have basically 2 types of problems, decision problems and optimization problems. What are decision problems and what are optimization problems? Decision problems are nothing but the problems which return the Boolean values as the solution, either true or false, or yes or no, like that answers. The problem gives the answer as true or false, or the problem gives the answer as yes or no. That type of problems are called as decision problems. Optimization problems means the problems which returns some optimal value as the solution. That optimal value may be either an integer or a real value or some other thing. Some optimal value can be returned as the solution. Those type of problems are called as optimization problems. Now coming to, for example, decision problems. For example, I am saying that can I color the given graph using 4 colors. I am asking a question which is nothing but can I color the given graph using 4 colors. Another question I am asking which is nothing but how many minimum number of colors required to color given graph. So out of these 2 problems, here I given 2 problems. One problem is can I color the given graph using 4 colors. That is first problem. And second problem is how many minimum number of colors required to color the given graph. That is second problem. Out of these 2 problems, which comes under decision problem, which comes under optimization problem? The first one comes under decision problem. The first one comes under decision problem. Here let us see how it becomes decision problem. Can I color the given graph using 4 colors? I am asking that can I color the given graph with 4 colors? So you say if it is possible to color the given graph with 4 colors, you can say the answer yes. If it is not possible, you can say the answer no. That's why the answer for this question is either yes or no. That's why we are saying this is a decision problem. Let us see the second one. Obviously the second one becomes an optimization problem. How we are saying the second one as optimization problem? How many minimum number of colors required to color the given graph? Here I asked the number of colors required, minimum number of colors required. I can say 2 colors I required or 3 colors I required or 4 colors I required to color the given graph. Like that we can say. That is we are giving some optimal value, either 2, 3, 4, 5, 6 something based on the given graph. Since we are giving an optimal value as the answer, this problem is called as optimization problem. Right. Here our dynamic programming is used to solve optimization problems. It is used to solve optimization problems. And like divide and conquer method, dynamic programming solves problems by combining the solutions of subproblems. You can understand that in case of our divide and conquer problem, we are going to divide the given problem into subproblems. Those subproblems are solved and the solutions are combined to get the solution of given problem. In the same way, what we are doing in case of divide and conquer method, in the same way we are going to do in case of dynamic programming also. Here also we are going to solve the problems by combining the solutions of subproblems, But there is a difference between divide and conquer and dynamic programming. What is the difference? There subproblems are present, here also subproblems are present. In case of divide and conquer method, we are dividing the problem into subproblems. In case of dynamic programming also, we are dividing the problem into subproblems. What is the difference then between those two? In case of divide and conquer method, the subproblems are independent of each other. They are independently solved. In case of dynamic programming, the subproblems are dependent of each other. Dependent of one subproblem is dependent on other subproblem. By solving this subproblem only, we can solve that particular subproblem. Like that, one subproblem is depending on other subproblem. Okay, now let us see the next one. Moreover, dynamic programming algorithm solves each subproblem just once and saves its answer in a table. In case of dynamic programming, the subproblems are solved. After solving each subproblem, we will get solutions. Those solutions are placed in a table. The process of placing all those solutions into a table is called as memoization. The process of storing the solutions of subproblems in case of dynamic programming is called as memoization, thereby avoiding the work of recomputing the answers every time. That is why we are storing those answers. Subproblems answers in a table means if we encounter the same subproblem in future, without recomputing that subproblem, we are going to access its solution from the table. That is, we are avoiding the recomputing. So, if we get the same, in case of divide and conquer, we are not storing the solutions. All those subproblems are independent. So, even you may get the same subproblem, you need to solve that also. You need to solve that subproblem also again. But in case of dynamic programming, we are solving the subproblems and solutions are tabulated. That process is called as memoization. Because of that tabulation, we are going to avoid recomputation. That is, in future, if the same subproblem is occurred, no need of again calculating that. We can access its solution from the table directly. Now, dynamic programming is a bottom-up approach. We solve all possible small problems and then combine to obtain solutions of bigger problems. It is a bottom-up approach. Bottom to top, we are going to solve the problems. That is, we are going to solve smallest problems to get the solution of larger problems. Okay. Right. What are the various steps that involved in the dynamic programming process? Here we have basically 4 steps in dynamic programming process. What are those 4 steps? First step is, what is the problem? Second step is base cases. What are the base cases? And third step is memoization. And fourth step is coding solution. Here what the 4 steps that we have in dynamic programming process? The 4 steps are, what is the problem? What are the base cases? What is memoization? And coding the solution. Now, what is the problem? What we are going to there in that step? In that step, we are understanding the given problem. We are understanding the given problem. What is the problem? What are the subproblems? What would be the solution roughly look like? What is the given problem? We need to clearly understood the given problem, and we need to get what may be the subproblems for the given problem. What may be the subproblems for the given problem and how our solution looks like. That we need to understand. And later, base cases, which is nothing but recurrence. That method is also called as recurrence. What is that recurrence? What decision do I make at this particular step? What decision I have to make in the previous step to come into this step? What decision I have to take at this step to reach the next level of solution? So, each and every step is very crucial. Each and every step is very crucial in reaching the solution. So, what the decision I am taking in previous step, what the decision I am taking in this step, what the decision I am going to take in the next step. All these things plays a very crucial role in getting the solution of these various applications or problems. Now, memoization. Already I said you that memoization means tabulating the results of subproblems. Tabulating the results of subproblems. Here, how many variables are there and how many subproblems are there and how big the subproblems are and after how many repetitive subproblems may be there. Now, what may be the size of the table what may be the size of given table for the given input. All those things should be decided at this step. Now, next, finally, code it. Code it is nothing but the last step where we are going to get the solution. So, after calculating all the subproblems, after finding the solutions for all the subproblems, from all those subproblems solutions, how I am going to get the solution? How I am going to get the solution of given problem. So, that is to be called as coding solution. So, what the 4 steps that we have? The first step is, what is the given problem? You need to understand the given problem. You need to understand what the subproblems may be present in the given problem, and you need to understand what the solution should be look like, how the solution is for that particular problem. The second one is base cases, which are nothing but recurrences. What the decisions that I am taking. In the first step, what the decision I am taking. In the second step, in the third step, in the nth step, in the n+1th step. What the decisions I am taking to get the optimal solution. And the third one is memoization, which is nothing but the tabulation of the results. Here we need to decide what is the size of the table for the given input, and finally code the solution. After getting all the solutions, we can write the solution for the given problem. How to write that particular solution. So, all these are the various steps that are present in the process of dynamic programming. Now, coming to the next one, what are the various components that are present in dynamic programming? Here we have 4 components. Those 4 components are stages, states, decision, and optimal policy. What are the 4 components that we have? Stages, states, decision, and optimal policy. Now, what about these stages, states, decision, and optimal policy? Stages means what the various stages of the problem. What the various stages of the problem. The problem is in the stage 1, or it is in the stage 2, or it is in the stage 3. What are the various stages of the problem? Now, states. What are the various states? That is, as the problem changes its stage, it also changes its state. That is, initially the problem is in the unsolved state. Initially the problem is in unsolved state. So, from unsolved states to solved state, here we are getting finally the solution. From unsolved state to solved state, there are various states. That is, 25% of problem solution is completed, 50% of problem solution is completed, 75% of problem solution is completed, 90% of problem solution is completed. So, when the problem comes to, here it is in 0%, we are not getting any solution. Here we get the solution, that is, it is 100%. So, 0 to 100% we are moving. From one, that is initial state to final state, we are moving from 0% to 100%. 0% means unsolved, 100% means completely solved. Now, in between these two states, we have various states. 25% of the problem is solved. If suppose for example, your problem contains 10 subproblems. Out of all those 10 subproblems, if I solved 2 subproblems, 2 by 5th part of my problem is solved. If I solved 5 subproblems, 50% of my problem is solved. If I solved 9 problems, 90% of my problem is solved. So, like that, it is present in various states. Okay. So, as the process changes its state, the states are also going to be changed. In stage 1, so here in stage 1, the problem comes to 0 to 25%. In stage 2, it comes to 75%. In stage 3, it comes to 100%. Stage 1 contains 2 levels, 0% and 25%. Stage 2 contains 2 levels, 50% and 75%. Stage 3 contains 2 states, 90% and 100%. Here, stage 1 contains 2 states. Stage 2 contains 2 states. Stage 3 contains again 2 states. Totally 6 states are there in solving my problem. Like that. As the stage is changed, the states are also automatically changed. But within one stage, the state may be changed from one position to another position, right. The third component is decision. I already said you that what decision that we are going to take in this step, in the next step, at 0% state, what the decision I am taking to get my problem solved to 25%. At 25% state, what decision I am taking to solve my problem to 50%. Like that, what the decisions that I am taking, that is called as various decisions. And the fourth one is optimal policy. Whether our problem, after completely solving my problem in the solved state, after completely solving my problem, whether the solution I obtained is optimal solution or not. There may be a lot of solutions. All those are feasible solutions which are satisfying the given constraints are called as feasible solutions. But all the feasible solutions are not optimal solutions. Which satisfies the given criterion function is called as optimal solution. Whether the obtained solution is optimal solution or not, we need to check that optimal policy. So, what the various components that are present in the dynamic programming process? Various stages, various states and decisions. Finally, the optimal policy. Next, coming to the characteristics of dynamic programming, there are mainly two characteristics are there for dynamic programming. One is optimal substructure and other one is overlapping subproblems. What is optimal substructure? I already said you that the solution should be optimal. So, at every state, we need to verify whether the solution is optimal or not. So, if we not verify, we will not get an optimal solution. So, that is why every substructure, every subproblem should be optimal. Okay. Next, overlapping subproblems. I already said you that here the subproblems are dependent on one another. In case of dynamic programming, the subproblems are dependent on one another. That is, they are overlapping subproblems. These two are the main characteristics of dynamic programming: optimal substructure and overlapping subproblems. Right. Now, principle of optimality. What is principle of optimality? In solving any application by following dynamic programming algorithm design strategy, we are following this principle of optimality. What is that principle of optimality? The principle of optimality is the basic principle of dynamic programming which was developed by the scientist Richard Bellman. Here, that principle of optimality is developed by the scientist Richard Bellman, which is the basic principle in dynamic programming algorithm design strategy. Now, what is principle of optimality? The principle of optimality can be stated as an optimal path has the property that whatever the initial conditions and control variables over some initial period, the control or decision variables chosen over the remaining period must be optimal for the remaining problem, with the state resulting from the early decision taken to be the initial condition. Simply saying, what is the principle of optimality means, whatever it may be the initial decisions that you taken, whatever it may be the initial decisions that you taken, whether the initial decision may lead to optimal solution or not. They may lead to optimal solution or may not lead to optimal solution. The decisions that you are taking in the later states should reach the optimal solution. Whatever it may be the initial state or initial decisions you taken, based on those initial states, what the decisions that you are taking in the next states should lead to the optimal solution. That is the principle of optimality. So, I hope you all understood the general method of dynamic programming. I'm going to summarize the concepts what we discussed in this session. In this session, we discussed what is dynamic programming, what is the comparison of dynamic programming and divide and conquer method, and what are the various steps that are present in dynamic programming, and what are the various components that are present in dynamic programming process, and what are the characteristics of dynamic programming process, and also the main principle of optimality what we are following in dynamic programming. All these concepts that we discussed in this session. To assess yourself, here I given some questions. Please answer these questions. The first question is, dynamic programming can be used to solve option A, decision problems, option B, optimization problems, option C, both decision and optimization problems, option D, none. The next question is, in dynamic programming, option A, subproblems are not present. Option B, subproblems are solved and solutions are tabulated. Option C, no need of solving subproblems. Option D, none. The next question is, write a brief note on the general method of dynamic programming. In preparing this presentation, I used the digital content from various public sources. This is used only for educational purpose and not for the commercial purpose. Thank you for listening the session.